Hello everyone. I'm very happy to join your class today. My name is Mansour Sodagari, and I'm going to give you a presentation about life cycle cost analysis, which is part of my PhD research. And in this video, I will introduce some basics about LCC, and we will do some examples and exercises. Before we start, I'd like to introduce myself briefly. Um, I'm a PhD candidate in construction management at Rinker School, University of Florida. I hold a bachelor's degree in civil engineering and a master's in health, safety, environment, and I'm about to graduate with my PhD program in construction management. My research is mostly about data analysis in life cycle cost analysis, and in my research, I worked on a couple of different case studies. One of them is Kennedy Space Center headquarters at NASA in Titusville, Florida. And also, I worked on a Smithsonian Museum, which is called NAMOC, or National Museum of African American History and Culture at Washington, D.C. And also, I studied some healthcare facilities like Shands Hospital, which is a UF hospital. And also, I've been in construction in different projects for more than 10 years. This presentation is about lifecycle cost. And as its name shows, it's around cost. So it's good to have some good understanding what cost means. And probably when you hear the word cost, the first thing that pops into your mind is money, which is somehow correct. According to Merriam-Webster, we can define cost as the amount or equivalent paid or charged for anything. And we know that cost estimate is one of the most common activities in any construction project. Maybe you've had some courses and you've learned about cost estimate, maybe in your courses or internships or job experiences. And by estimation, we mean some type of calculation and predicting of the future cost of a project. And we do estimation to prepare an approximate realistic cost of a project in an orderly, efficient, and comprehensive manner to kind of guarantee the success and profitability of the project and to keep our business running. Cost estimate is one of the first steps in any project, and it starts at the bidding phase. Regardless of the winning or losing the bid, we need to calculate the project cost to the best of our knowledge. And we know that typically the lowest bidder wins the project, so it is vital to make sure that we predict all the expenses and also that we add our margin to keep everyone happy, the owner, the architect, subs, and most importantly ourselves. A good cost estimate can avoid RFIs, change orders, and lots of delays. So it's very important to predict everything, all the costs that can happen along the project. And typically, we start estimation with quantity takeoff after we receive the contract documents and maybe after we draft our own shop drawings. We start doing the quantity takeoff, and then with the unit prices, our own data sources, we do the cost estimation. And typically, it includes purchasing materials, equipment, machines, and also labor costs. And maybe after during the project, after we start the project, we have some change orders, so we need to get back to our cost estimation and update the cost. Also, there are some indirect costs like overhead and markups, and some other like expenses that we have to add to the project value, like the tax, permits, insurance, bonds, and some other indirect and hidden costs. As we know, there are different trades involved in any construction project. For example, in a residential project, we know that we have different trades like investors, designers, and contractors. And each of these trades have their own perspective towards cost and the project value. For example, investors might consider the market value and they are mostly interested in finishing the project with the lowest cost, with the lowest price, so that they can sell the project as soon as possible. And this way they can keep their cash flow and make the most profit out of it. And also focusing on the profit and the benefits maybe doesn't allow them to think about what happens to the structure or the MEP systems in the building, like a couple of years after selling out the project. And also, maybe they don't care about the residents' comfort and quality of life. From a designer perspective, it's different. Designers typically try to meet the minimum requirements of the building codes to reduce their workload and to keep the construction process and operations as easy as possible and as fast as possible. Also, contractors, they may select just the available equipment um, just to kind of reduce the shipping time and avoid any delays. And maybe they recruit the cheapest subcontractors who may not deliver the highest quality. And so this way they can reduce the total cost of the project. Buyers who, for example, people that they are interested in that house, in that building, and they want to buy that house, maybe they just care about like some other metrics, like for example, they find some available projects, some available houses in one area, and they compare the prices. They will definitely check the layout, and they may care about the number of bedrooms, the location of that building, the neighborhood safety, and some of these type of variables. And it's the same story for the renters. Probably the rent amount is very important, the square footage, location, and like the vicinity of that house to grocery stores are some important things to a renter. But if you want to build your own house, what variables would you include in the design and construction? Since this is gonna be your house where you and your family will be living maybe for a long time, probably you pay attention to some other things and maybe you adjust the total cost of the project based on your like ideas and the level of comfort that you are looking for. But definitely it starts with the first cost, which includes uh, the design and also construction operation. And also you may look for different building components like flooring material or exterior walls, and you may change the interior design, or maybe you ask the designer to um, kind of adjust the design based on what you want. And also, maybe you compare different systems like mechanical systems, AC systems, plumbing, and electrical, which can affect your utility bills during the life cycle of your building. And also, each of these components, they have some maintenance costs. Some of them require more maintenance during the ownership of that building, and maybe you need to replace some building fixtures, some systems in your building, and also you have to pay attention to the structure. We have different types of structure, and each location, maybe some structures work better, and definitely they come with different costs. And also, maybe you think about how much you will be able to sell your building after a number of years when you want to move out, and which is called salvage value. And also, there are some other metrics, some other risks related to each facility that you may take them into account. After identifying the cost related to your own building, it's time to calculate the life cycle cost, or LCC. For that purpose, we put all the costs next to each other. Some of them are entered with a plus sign, and some of them are entered with a negative sign. So for example, the first cost, or utilities cost, is something that you have to pay for it. But the salvage value is the money that you can make by selling your building at the end of your ownership. And here, by looking at these costs, we understand that they happen and they occur at different points in time. For example, the first cost is the amount of money that you have to spend today, or the utilities is something that you need to pay every month until the last day of ownership. Uh, but on the other hand, we have maintenance and replacement that are not going to happen all the times. Maintenance, maybe you need to, I don't know, repair some of the building components once in a while, like every 2 years, 3 years, 5 years, depending on that type of component. And also replacement is, for example, for those cases that, for example, the AC is broken and you need to change the whole system. And maybe replacement happens like after 10 years or 15 years, and it's not something that you need to pay for it frequently. And we have the salvage value, which is the amount of money that you can make by selling your building when you want to move out from your building, and this way you have to deduct it from the LCC cost. But the problem is that these costs, they occur at different points, and we don't have an equal time basis. And we know that, for example, the like $1,000 today is different with $1,000 next year, or with $1,000 after 10 years. But how can we calculate these costs, and how can we convert them to one equal time basis amount? Here we need to consider something called time value of money, which I'm going to talk about it in the next slides. But I'd like to start with an example. In 1626, a German guy purchased the island of Manhattan for $24 from Native Americans. The current value of that $24 after 395 years, with a discount rate of 7%, equals to $9.7 trillion as today's value. It means that if the Native Americans, they had invested that $24 and they had made 7% profit from that investment every year, after like almost 400 years, they could have $9.7 trillion. It's interesting to know that that small amount of money of $24, it could turn to such a big money after 400 years. And it's interesting to know that the today estimated amount of that land is approximately $825 billion. So it means that by investing that $24 back in 1626, they could make almost 12 times more than the present value of that land. But here, as you see, we are working with two parameters here. One of them is the number of years, which is 395, and also something called the discount rate, which is 7%. And these are things that we need to calculate LCC. So after reviewing the example of the Manhattan Island, we realized that the value of money changes over time. So I'm going to ask you a question. Suppose your friend needs $1,000 today and he or she promises you to pay back the debt after 1 year. But how much will you ask your friend to pay you? $1,000? Because you may say that this is the amount of money that you borrowed your friend, and maybe it's fair to ask for the same amount. But then maybe you consider the inflation rate. We know everything is getting more expensive every year, and we know that the inflation rate this year is something around 8.3%. And if you add that amount to the debt today, it will be something around $1,083. But then maybe you remember that you wanted to buy a scooter with your money, and some scooter that you know and you wanted to purchase. It was $1,000 last year, but this year it's $1,200. And you may think that, okay, if you want to buy the same scooter after 1 year, maybe it will be more $200 more expensive. So will you ask for like $1,200, or maybe you even add the inflation rate and ask for $1,283? But your friend can tell you that, yeah, I will pay you $200 more, but I believe that this $200, this price increase, kind of includes and covers that inflation rate inside of it. And maybe then you believe and you think that you can invest this money, this $1,000, in a type of business, something like the digital coin, which is very like popular these days. And you believe that you can gain $300 profit in 1 year. So it means that if you save this $1,000 for yourself and invest it, after 1 year, you can make $1,300, and you may ask your friend to pay you $1,300. But what is the exact and correct time value of money in this case? The answer is that there's no correct and exact answer, because you have to determine the time value of money based on the available opportunities that you have, or the type of investment that you can make, and the type of risks that you can take, or maybe you just want to be generous. So it means that you, this like price increase and the value of $1,000 after 1 year can fluctuate based on your opinion and based on your decision. In this slide, I want to define some economic metrics, including inflation rate, escalation rate, and discount rate. Inflation rate refers to an overall increase in weighted average of prices for different goods each year. In the previous example, inflation rate was 8.3%, and it's the same amount of money that when you go to buy something, like when you do the grocery and you notice that the price of some items has changed from last year, and you get surprised. Another term is escalation rate, and it's actually the current cost or value minus the initial price or value divided by the initial price in a 1 year period. In the previous example, escalation rate was that $200 of the scooter price. Also, we have the discount rate, which is actually the profit that you can make from a business or an investment, like that $300 of investing in digital coin. Typically, discount rate is something between 4% and 15%, and it is determined by the individual investor or organizations. And the organizations, maybe they determine this amount based on their historic data and previous projects. Now let's define time value of money once again. So we can define it as discounting dollar amounts usually occurring in the future to time equivalent amounts at a common time. And we need this to purchase goods and services, to invest for earnings, to pay off our debts, and also to avoid borrowing. But how can we calculate the time value of money? If you want to convert a present value to a future value, you use single compound amount. And you use this in lending $1,000 to your friend to find out how much you should ask after 1 year. But if you want to convert a future value to today's money, you use single present value. So it means that in building your house example, if you want to know how much the salvage value or the value of your building is in today's money, you use single present value. Let's look at an example together. Suppose you want to make an investment and you find a land that cost you $100,000 today and you want to sell it after 5 years and expect to make 8% profit out of this investment. But how much should you sell it? So in this case, we use single compound amount where the discount rate is 8% and the number of years is 5. So maybe you say that 8% is $8,000. So if you add it to the initial investment is $108,000. But as we know that the value of money shrinks over time, and if you want to make sure that you make that 8% profit, actually you have to sell this land for an amount equal to 146,900,000 dollars. So it means that 8% today is equal to something around $47,000 after 5 years. After learning about how to calculate the time value of money, now we can get back to our LCC calculations. If you remember from the building your own house example, we lined up all the costs to calculate the LCC. But now we have to consider the time value of the cost and convert them to the present value, including present value of the investment cost, present value of utilities, present value of repair, present value of replacement, minus present value of salvage value. This way, we've accounted for all the future costs and the time value of all the costs at different times. Now we can have a better understanding of what LCC means. LCC or life cycle cost analysis is an economic method of project evaluation in which all costs arising from owning, operating, maintaining, and ultimately disposing of a project. Typically, in LCC calculations, we compare two different projects to make the best decision and to select the best project which has the lowest LCC over the time period of our study. All right, I think now you are ready to do an exercise. So let's get back to build your own house example. You have two options to pick. Option A is a traditional design, and option B is a smart building, which has some advanced technologies. And definitely, these two options they have different cost over the life cycle period. So what I want you to do is to calculate the LCC for these two projects, compare the LCC, and select the lowest LCC as your favorite project. In this exercise, we assume that you want to sell your building after 30 years, and the discount rate is 2% for all of the costs. The first cost of option A is $200,000, which is less than option B with $300,000. Utilities, maintenance, and replacement costs are given in present value, and it means that you need to calculate the future value. Replacement cost in option A um, is about the MEP systems that need to be replaced every 10 years, and in option B, the MEP systems need to be replaced every 45 years, which is longer than the time of ownership. Salvage value is given in future value, and it means that you have to discount it back to present value. And this salvage value does not include the MEP replacement cost. I hope this example and this exercise is clear to you. Um, I will review the answers next session when I join the class online. And in the end, I'd like to appreciate you for taking the time to pay attention to this presentation, and I hope that it was helpful. Thank you so much, and see you soon.